Hi, welcome to this video about using statistical modeling tools that I've developed within the RMRS Raster utility to perform analyses you'd commonly do in something like SAS or R. In addition, though, to just statistical analyses, we've built a whole suite of machine learning tools, and they all work within this function modeling concept where delayed reading and delayed processing is occurring. So just like in the previous video where we had to load certain tools into the toolbar, here again we need to use the customization tool, and we want to go to the commands tab once we have this loaded up and go down to stats. Notice that it's lowercase here. All the tools I've built have lowercase names. And within these tools we have a wider range of things, from accuracy assessments to adjusted accuracy assessments for new areas based off of a previous sample, build rasters for models, cluster analyses, compare classifications, compare samples to populations, and so on and so forth. If you don't see these tools within your statistical modeling menu, you can simply grab one of these tools and drag and drop here. And just to kind of give a quick overview of these tools, I'm going to run through some of them just by their name and kind of briefly describe what they do. So with our accuracy assessment, really what we're creating is a contingency table where we're looking at the number of times we've correctly classified one category versus the times we've incorrectly classified it. We have a nice set of user forms where we can specify the table, the field we mapped, our reference field, if we have some sort of weighting variable, and then the output accuracy assessment, which is generally just a form, or is a form that you can look at. But in addition to that, we can adjust our accuracy assessment. Say we've calculated an accuracy assessment for the entire map, and now we want to look at a sub-region within the map, and we want to get at what are the prior proportions of each category, then weighted by the accuracy assessment. This tool will help you accomplish that task. We can compare classifications. We can look at a table where we have one classification that looks at a map field and another classification looks at a mapped field, and then we can look at the truth. What is the reference field? And from that we can get at, are those two classifications different? We have a whole suite of statistics that are put out, and you can look at those numbers and statistically determine whether the classifications are different. We have some other generic tools for variance covariance, stratifying variance covariance, getting at sample sizes, performing principal component analyses, comparing a sample to a population to look at the distribution in terms of predictor variable space and see whether or not those variables are the same. We have a workshop, or see whether or not the distribution of those variables in multidimensional space are the same. We have a workshop devoted to this where we hit on some of the ideas behind how you would use this to set up a sample that represents an entire population and spread samples out so that you capture that entire distribution that's both balanced and weighted accordingly so that you get all that information. We can perform t-tests, do cluster analyses, linear regression, generalized linear modeling, in which we can define a number of different links for our modeling. And really the key with all of this stuff, just like it would be with using R or SAS, is that you've created a table of values. You can use some of our other tools within sampling and raster analysis to manipulate raster surfaces and then extract data and summarize it either at the polygon level or at a point level. And you can do other types of analyses like logistic regression, multinomial logistic regression, softmax neural nets, and random forest. Additionally, I've built some tools to utilize LiDAR type data using Fusion and automating that and running it in hyperparallel depending on how many processors you have on your machine. So you can really get it moving things fast. And these tools work in many regards for both vector and raster data sets. And if we're dealing with raster data sets, we can build rasters from a model. But if we're dealing with a vector data set, we can predict new data values. So we have quite a bit of flexibility here on how we use these models that are created to generate new predictions across that landscape. We can show some model reports to get basic statistics, how accurate, how precise are our models. And we can delete models and manipulate them through here. We can also format zonal data, or take zonal data that is in multi-band format and transpose it so that it attributes our vector vector data sets with multiple fields. We can do a bunch of summaries by fields. We can summarize by related tables. And we can do spatial summaries where we're summarizing plots at the polygon level. And then furthermore do spatially weighted averages and split a number of polys. So I challenge you guys, or I hope you guys get a chance to go in and check some of these tools out. Check out some of the other tutorials and workshops that highlight some of this functionality. And happy modeling. Thanks for listening.